Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Moka, and I am your instructor. Today, I'll be showing you the part 13 of this 16-story building, and on this part 13, we will be performing the structural analysis and design of this 16-story building that has a swimming pool at the top of the 16th floor. So right now, on our recent part, which is the part 12, I showed you guys how to apply your load on this retaining wall of this swimming pool. So on this part 13 now, we'll be performing the structural analysis and design for this 16-story building. So I'll urge you to sit tight and then let's go through the design of this 16-story building. Now, for those of you who are new on Ekidel and you are seeing this video for the very first time, this video has up to 13 parts as of today. So you can watch other parts of this video and all that, and to follow up of this video you can get the card file from the link down below and then follow us up to what we are doing for today. So right now let's begin. Okay, so when performing a structural design for a high-rise building in ProtaStructure, there are two methods you can use, either to use the finite element method or you can use the yield line method. So the most common and the most conversant one is to use the yield line method. Okay, so we will be using the yield line method for the design and also for the analysis of this structure. But before we will use the yield line method, there are some settings that we are meant to do, and those settings right now I will take you on that. So right now, to begin the building analysis and design of this structure, the first thing you do is to go here and click on what analysis tab. Now once you click on that right now, you can see that our building design or analysis is not yet performed. So I'll click on this right now. So once I click on this now, a dialog box will appear. Now on that dialog box just now, we will have to make some settings because you can see that there is a swimming pool at the top here. So to be able to carry the weight of that pool down to the vertical members, which is the columns and walls, then we will have to make some settings. Okay, so right now on this interface now, the first thing we're going to do is to go to the place that says model option. Now these settings that I'm going to do right now, this particular one, you must not do it for every of your structural design. So the reason why I'm doing this is because of this swimming pool at the top here. So right now, in that course, I will have to come here right now that says shear wall model. So since I want to use, now for this, because of this pool right now, I want the load of this pool to transfer evenly to the vertical members. And by doing that, I will have to use a finite element shear wall method. So I'll come here right now and then click on this and say finite element shear model. So if you don't use this, then the weight of this pool will not be able to be transferred evenly. But you can only choose this. Don't forget, when you're doing the kind of design for swimming pool that is at the top of a building, that's only when you choose this. For the conventional design which you're doing for a one-story normal design that don't have all these kind of things, don't make sure you don't come and choose anything here. Okay, so that's just okay. Yes, also to add to what I just recorded before, now you can see that finite element shear model which I just picked there can also be used when you are designing for a silo. Okay, so whenever you are designing for silo, silo is like a structural element that can be used to like store grains like rice, beans, like grains. Okay, and majorly it is like an agricultural structure. So whenever you're designing for structures like that, you can use that finite element model method to be able to transfer the load evenly. Okay, so this is just to add to what I just said on the video. Okay, so that's that for that. Now apart from these settings, every other settings that I'll do right now is just normal, and you are meant to apply it for your design or analysis of any structure. Okay, so this is only setting that is just separate based on this structure. Okay, so with that now, I will now come here and then click on this place that says pre-analysis here. Okay, now once you come to this place now, the first thing you do is to edit your materials. So I'll come here and then say edit materials. As you can see, I am using Eurocode for the design. I am using Eurocode UK Annex for the design of this structure. Okay, so right now, once you click on the material tab, you will now see this material interface. The first thing I'll do right now is to choose my concrete grade, okay, which is the grade of concrete. So I'll come here just now. Now, since this is a high-rise building, I would like to use a bigger grade of concrete, because normally I used to use my concrete grade to be 20, but since this is a high-rise building, I want to use grade 25. Okay, so I'll click on this right now and then choose to apply all main bars for column, walls, slab, and beams. Okay, so I'll come here and then click on what? Okay, and everything will change automatically to the concrete grade. So right now we will now enter into the reinforcement or steel grade. When you hear steel grade, this is not a universal steel like I section. No, this is like a reinforcement grade of steel. So I'll come now and then click on this place here, one of them here, and it does not show the dialog box will appear. Now you can see that we'll have different grades of steel, as you can see that. Now I always advise that for young engineers or even for professional engineers, mind the way you choose your grade of steel if you are in Africa and most countries that don't pay much attention on qualities when it comes to manufacturing industries. Okay, for countries like US, Canada, Spain, and all that, most advanced countries, you can choose a grade of steel of 500 because the strength of those steel or let me say the strength of material produced in those countries have been checked, and they have made sure that the strength is up to 500. But for countries like Africa and part of Asia, where some things are being compromised, so just not to have issues on your reinforcement, I would advise you just choose 410 as your grade of steel, which is the strength of your steel. Okay, so once you choose that right now, you can choose 410 or you can choose 460. But for me, I always choose 410, except I have a very good confidence that the company that I'm buying the steel from has a good reputation. I can now go and do that. Okay, but I would advise you just pick 410 for safety purpose. Okay, so right now I'll come here and then click on this that say apply to all members again. Now before I'll say okay, I will have to edit my rebars. So if you are using other version of ProtaStructure, you can skip this particular stage here. But for to do version of Prota, you must follow this stage. So I'll come here right now and then pick my rebars, which is the bar size for column, for beams, and all that. Okay, so right now you can see that there are several lists of this icon right now symbolizes column, here symbolizes wall, beam, slab, rib slab, and footing and links. So right now you can see that we have all these members or elements on this our 16-story building. Okay, so let's start with column just now. So for the column right now, you are meant to pick the bar sizes or the diameter of the reinforcement that you want to use for your column. Now based on Eurocode specifies that the minimum bar size for column should be 16. So if you don't have 16 yet, just pick 16 as your reinforcement, and then the maximum can be any value, but the minimum diameter of bar should be 16. So from experience, I would say that 16 is the minimum based on code. Then I'll also add 20, as you can see that 20 and 25. I'm not going to add 32 or 30 because this size of reinforcement, they are too big for me to choose that. And if you choose a higher reinforcement, more than 25 diameter, you might end up wasting the client's money and all that. So instead of using a higher diameter, more than 25, you can quickly go and increase the size of the column. That will be safer. Okay, that will be more cheaper and also safer. Okay, so right now I've picked my column bar size now 16, 20, and 25. Okay, so if maybe yours was clicked like this before, you can just go and uncheck the rest and pick 16 as a minimum. Now for my wall reinforcement, BS code specifies that the minimum bar size to be used is 10 basically, but me, I don't like using 10 because 10 diameter of bar, I use them for links. So I go ahead and then go and choose 12 as my minimum bar size for my reinforced concrete walls, and I also choose 16, 20, 25. So make sure you choose all these, as you can see that there. Then when it comes to beam, Eurocode specifies the same thing that is set for column as also for beam, that for floor beams, the minimum bar size you are going to use is 16 diameter, and then so on and so forth. So from experience, I'll pick 16, 20, and then 25 too. That's okay. Then when it comes to slab, which is the reinforced concrete solid slab, Eurocode specifies that you can use 10 diameter and also 12 diameter and all that. So for me, I don't like using 10. I like to use just one bar size. So I like to use the most common bar size for slab, which is 12 diameter. Okay. Then also when it comes to a rib slab, this is the rib slab. In this structure, as you can see here right now, we use a rib slab for this structure, which is basically waffle slab, which is also a rib slab. So for rib slab, you have to choose 10 and what? and what 12. So the reason I'm choosing 10 is because there will be a secondary bars for rib slab and all that, and rib slab also have a strips of beams, so that's why I'm using 10 and 12. Okay, then for my footing, basically this is for footing, and this footing simply means a pad foundation. Knowing that this is a high-rise building and this is a 16-story building, I will not be using a pad foundation for this. But even at that, the software does not require you to leave it as vacant. So make sure you pick bar size. Don't leave it as vacant like this because it will not work. The software will show it as error. So make sure you pick some few size of bars. So I'll just say you should pick 16 and then pick 20 and then 25. That's okay. Then when it now comes to lengths, things are used for columns and for beams and all that, and even for pipe foundation they also use lengths, okay, and all that. So right now for lengths, you of course specify that you use your minimum lengths to be 8, but for me I don't like using 8, so it can be 6, but 6 is very tiny to be used as a diameter of lengths for this kind of structure. So I will use 8 and what 10 and 12. I don't want to use 8 for the links, although 8 is very common, but me, I don't like using 8, I like to use 10, okay? So I'll use my that, 10 and 12. Then, this other one now are what? Generics and all that. So just leave all these other ones here as default, as it is, and all that. So make sure you pick these ones which I have picked for column, wall, reinforced concrete wall, for beams, for slab, for rib slab, and for footing, okay? So once you're done with that right now, you now go ahead now and then can click on what? OK. Okay, so right now, once I click on OK, I'll now go again and click on the final OK here. And then click on the final OK again here. So with this now, you can see that, let me see again if that's, okay, yes. So with this now, you can see that we are done choosing our material sizes and members for that. So the next thing now we are going to move on to now is to now begin to perform our analysis, okay? So right now, because we have already added all the windows before, so I'll just come here right now and then click on what analysis tab here. Now, before you must begin your analysis, basically for a high-rise building, you must do what they call building model check to check if your building model is okay. Now, what I mean by building model, to check if the connection between the beams, the columns, the walls, and everything are okay, and even the slab, if there is any form of slab overlapping with a beam or column, then you'll be able to see it here. So right now, we will have to click on this building model check and see if there is anywhere that is say error, either due to overlapping, then we will know. So I'll come here right now and then click on what? Building model check. So on this right now, you can now see that these are the things that this software are going to check. First, to check for what slab overlapping, for column overlapping, because most times you might mistakenly insert two columns at the same point. So that's what this software will check and all that. So to check out our model right now, if it is okay, before we can now begin the building design analysis, then we'll have to now begin to click on what? Start here. So by clicking on start now, it will have to check for errors if there is any form of overlapping and all that. So let's confirm right now. So if you're following up this video, make sure you do on this check. Now, once you find any error on your own, then just go and correct that error. You can also, but I believe if you're following what I'm doing, you'll be having that error and all that. Okay. So right now, you can see that it has not done. It is not done with the building model check, and you can see that building model check completed. Numbers of errors is 0. So if yours is not 0, you are not permitted to continue to the next part, which is part 14, which is focusing on the structural analysis. So make sure that your building model check is 0. If it is not 0, then you have issues on your model. You must have to go and check back again on your model and rectify that. And also, if you're having issues, this software will list down the issues for you. Let me assume that if this slab was like trying to overlap with another slab or beam, you will see the errors there and where the fault is coming from. It will show you the story. So what you do right now is to just go to that story and correct that error and make sure that error is free. And until you see numbers of errors 0 as you can see here, then you must not proceed to the next stage. Because the next stage, if you proceed without correcting this error, it might lead to collapse of your structure. So make sure you have no error on your building model check and all that. So right now with this now, you can see that there is no error with this model check. So I will now come here right now and then say close. So with this right now, our model is perfectly okay, and we can now proceed to building what analysis. Okay. Now this will be the next part, which will now be the build analysis stage, which will now be the part 4. So this is how so you can see that we have now chose our material for the design and everything, and we also perform building model check and everything looks okay. So we'll now go on to the part 4, which is now the building analysis, and then now go forward to the building design. So we'll now go to the part 14. Okay, so see you then right now. And if you have not subscribed to our channel Ekidel, I would say that you should please click on the subscribe button so that you don't miss our amazing videos. And also, for those of you that are new, I would say that you can also share this link to your colleagues and to your friends if you're a student, so they also know what's happening in your Ekidel. Ekidel is a global platform where we train civil and structural engineers and make them and help them to build their career. Okay, then also we are introducing a new structural instructor which will focus on structural detailing, because we have done much on design. So we are introducing a new structural engineer from Nigeria that will be taking on structural detailing, and he will be using Euro code and BS code standard of detailing for that. Okay, so this is just to bring to your notice that we have got a new structural engineer that will focus on structural detailing. So this is why you need to subscribe and also invite your friends and colleagues to know what's happening at Ekidel, to be able to help them to build their career. Our mission basically is to make sure that the world becomes a better place for all in the area of civil and structural engineering, and also to help to also eradicate structural collapse and failures when it comes to our environment. So thank you so much and God bless you. If you want to follow us up with this video, you can get the link down below and download the CAD file. It is not free and it's not also expensive, but it will help you a lot, because if you're using the CAD file that we are using and you're able to meet up to this very stage and complete this building up to the pipe foundation, then I can tell you that you are already 50% good, even if you are a fresh graduate. Although you still need to have some site experience and also construction experience, but for design stage, you will be able to have some enlightenment about design. So thank you so much and God bless you. We love you, and give this video a thumbs up, and then see you again on the part 14, which is now the structural analysis and design. Bye for now, and then goodbye.